So, graphing parabolas. This is considered our original function of a parabola. Okay? This is where we're really transforming everything from. Now, if you guys remember, when we put all the transformations together, it looks like this. We have an A, an H, and a K. This is known as the vertex form. Okay? The reason it's known as the vertex form is the H value is essentially the X value of the vertex, and the K value is essentially the Y value of the vertex. Okay? Now, there is one stipulation with the H. It's technically the opposite of what's ever in those brackets. Okay? So, for instance, I know you guys are used to seeing this by now. Let's say we had something like 2x minus 2. No, let's use different numbers so it doesn't get confusing for you guys. 3 plus 4. Okay? What that means is the vertex wouldn't be negative but positive 3, the x value of it, and the y value is still positive 4. So that's why they call this the vertex form. It's very simple to see where the vertex is, and in this case that would be at 3 and 4. Okay? But I don't want to start there. I want to actually go back. I just wanted to make sure you guys remember that. This form here. Now this can technically be written like this. In other words, I have to know what the A, the H, and the K value are in this instance. And I'm going to put that together for you right now. The function is usually written like this. Our A value, if nothing is written, is 1. The H value, if nothing is written, is 0. And the K value, if nothing is written, is 0. Okay? In other words, what that means is this is our H and this is our K. Our vertex is at 0 and 0. In other words, the origin. Okay? So the vertex of our parabola is at the origin. We're used to seeing that. And our A value is 1 in this case. The A value is very important when graphing because we have to use it every time we find a coordinate. So we start at the vertex. And if I was to graph this, I would go over 1 unit. And then whatever I go over by, I square that number. And the reason we square it is because quadratics are squared. Okay? This is like almost doing a table of values in our head. So I go over 1. What is 1 squared? 1. But whatever I go up by, I must multiply by the A value. So what is 1 times 1? 1. No difference. So in other words, to draw the next point, we went over 1 and up 1. So here's the next point. Same idea if we were to go to the left of the vertex. What's negative 1 squared? Not negative 1. 1. And then 1 times 1 is 1 again. So what you're going to notice is it also goes up 1 if we go to the left. Parabolas are always symmetrical. So whatever we do on one side, we're pretty much going to do on the other. We really don't have to duplicate that process every time. So let's say we start at the vertex again. We always go back to that. If I were to go over 2 units, what is 2 squared? 4. And what is 4 times 1? Still 4. So we go over 2 from the vertex up 1, 2, 3, 4 units. And then I duplicate that on the other side. Okay? Go back to the vertex again. Let's go over 3. What is 3 squared? 9. And what's 9 times 1? Still 9. So we go all the way up to the value of 9. Okay? So in other words, our parabola is written like this. Now this is the original one. And this is when the A value is of value 1. But in this case, we have a value 2 here. Now we've already found the vertex of this one. We plotted it. It is at 3 and 4. What we're going to do is the same process, but this time with an A value of 2, which is going to make things different. So always go horizontally across from the vertex. So if I go over 1, I square that value. How much do I go up? What's 1 squared? 1. So I go over 1, and then I have to take that 1 and multiply it by 2. So how many would I go up? 2. So I go over 1, up 2 units instead. 1, 2. And I do the same thing on the other side. I go over 1. 1 squared is 1 times 2 is 2. So here's the other point. I know I did that quick. Let's do this again. From the vertex, I go horizontally 2 over. What is 2 squared? 4. And what's 4 times 2? 8. So I actually go up 8 units. Not going to quite fit on this graph. That's okay. I'm going to estimate to where it would be. So I go from here 1, 2, 3, 4, 5, 6, 7, 8. So this is where the next point would be, and then identical on the other side. So when I go to graph this one, How would you describe this in relation to the first black parabola we drew? It's been stretched, or it's thinner than before. And we know that's correct because the a value is greater than 1. Therefore, it should be stretched. Okay? So let's try this now. Let's say we have a value f at x is equal to, let's say, negative a fourth. This one's a little harder. The other video I did this morning, we did a half. So if you get confused, that's fine. You can use that value. X plus 3 squared minus 1. Okay. The very first thing I want to do is find the vertex. What is the vertex of this one going to be? Negative 3 and? Good. Negative 3 and negative 1. So easy to see. So we go over 3, down 1. Here's our vertex. Before I even go about using that a value, let's look at the operation. What operation is it? Positive or negative? Negative, which means it will open which way? Down. So we know we're going to have something opening downward. So when we do our multiplication with this a value, we should get downward coordinates. So from the vertex, I go horizontally 1. What's 1 squared? 1. Now, what is 1 times the a value of negative a fourth? It's negative 1/4. So I go over 1, down a fourth. Negative means we go downward. So it's only a little bit we go down in this case. I do the same to the left. We go down a fourth. So let's do this again. Start at the vertex. We go over 2. What is 2 squared? 4. What is 4 times negative 1/4? Anyone know? Negative 1. Okay? It's just negative 1. Use your calculators if you're unsure. So we go over 2, down 1 instead. Same with the other direction. Over 2, down 1. Now 3 is going to be a tough one. Let's jump up to 4 over, okay? Just so you know you guys can do the math. So let's say I go over 4 units. 1, 2, 3, 4 units horizontal from the vertex. What is 4 squared? 16 times negative a fourth. Anyone know? Negative 4. So when I go over 4, I actually end up going down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. So here's our next point. So this parabola is opening downwards, like we said. Did I go over too many? Nope, that's right. But how would you describe this in relation to the original black parabola we drew? It's been compressed and it's flipped upside down, which makes sense. This value is between 0 and 1, right? Our a value was less than 1 but greater than 0. And it's a negative, so it's facing downwards. Okay? So we always have to multiply by our a value the way we would originally draw the normal one in order to graph the rest of the parabola. Okay?